Business statistics is the systematic process of collecting, interpreting, and presenting numerical data about business situations. In business, statistics is organized into two categories: descriptive statistics and statistical inference. Let's take a look. A table is a collection of related data arranged for ease of reference or comparison, usually in parallel columns with meaningful titles. Tables are a very useful tool in summarizing statistical data and are found everywhere in business. Once the data have been obtained from the table, they can be compared with other data by arithmetic or percentage analysis. In business, tables and charts are used extensively to summarize and display data in a clear and concise manner. A line chart shows data changing over a period of time. A single glance at a line chart gives the viewer a general idea of the direction or trend of the data, up, down, or up and down. A horizontal axis, or x-axis, is used to measure units of time, such as days, weeks, months, or years, whereas the vertical axis, or y-axis, depicts magnitude, such as sales dollars or production units. Frequently, the y-axis is used to measure the percentage of something. Line charts are actually a series of data points on a grid that are continually connected by straight lines. They may contain a single line representing the change of one variable, such as interest rates, or they might contain multiple lines representing the change of interrelated variables, such as interest rates and stock prices or sales and profits. Here are the steps to creating a line chart. Step 1. Evenly space and label the time variable on the x-axis. Step 2. Evenly space and label the amount variable on the y-axis. Step 3. Show each data point by placing a dot above the time period and across from the corresponding amount. Step 4. Connect the plotted points with straight lines from the chart. And finally, Step 5. When multiple lines are displayed, they should be labeled or differentiated by various colors or line patterns. Bar charts represent quantities or percentages by the length of horizontal or vertical bars. As with line charts, bar charts often illustrate increases or decreases in the magnitude of a certain variable or the relationship between similar variables. Bar charts may or may not be based on the movement of time. Bar charts are divided into three categories: standard, comparative, and component. Standard bar charts are used to illustrate the change in a magnitude of one variable. Comparative bar charts are used to illustrate two or more related variables. The bars representing each variable should be shaded or colored differently to make the chart easy to read and interpret. Each bar is divided into the components that are stacked up on each other and shaded or colored. Here are the steps to creating a bar chart. Step 1. Evenly space and label the x-axis. The space between bars should be 1/2 the width of the bars. Step 2. Evenly space and label the y-axis. Be sure to include the full range of values needed to represent the variable. The lowest value should start at the bottom of the y-axis and increase upward. Step 3. Draw each bar up from the x-axis to the point opposite the y-axis that corresponds to its value. Step 4. For comparative and component bar charts, differentiate the bars by color or shading pattern. The pie chart is a circle divided into sections representing the component parts of a whole. The whole, 100%, is the circle. The parts are the wedge-shaped sections of the circle. When this type of chart is used, the data are usually converted to percentages. The size of each section of the circle is determined by the portion or percentage each component is of the whole. Here are the steps to creating a pie chart. Step 1. Convert the amount of each component to a percent by using the percentage formula, where the portion is the amount of each component and the base is the total amount. Step 2. Because a full circle is made up of 360 degrees representing 100%, multiply each component's percent decimal form by 360 degrees to determine how many degrees each component slice will be. Step 3. Draw a circle with a compass and mark the center. Step 4. Using a protractor, mark off the number of degrees in the circle that represent each component. Step 5. Connect each point on the circle to the center using a straight line to form a segment or slice for each component. Step 6. Label the segments clearly by name, color, or shading. The arithmetic mean corresponds to the generally accepted meaning of the word average. It's customary to abbreviate the term arithmetic mean and refer to this average simply as the mean. Here are the steps to calculate the arithmetic mean of ungrouped data. Step 1. Find the sum of all the values in the data set. Step 2. Divide the sum in step 1 by the number of values in the set, where mean of an ungrouped data equals the sum of values over the number of values. Here's an example. Worldwide travel had daily sales of $4,635, $3,655, $3,506, $2,780, $4,309, and $5,475 during a given week. What is the mean sales per day? Next, find the sum of the values and divide by the number of the values as you see here to give us a mean of $4,075. The median of a set of numbers is the midpoint value when the numbers are ranked in ascending or descending order. Compared to the mean, the median is a more useful measure of central tendency when one or more of the values of the set is significantly higher or lower than the rest of the set. For example, if ages of 5 individuals in a group are 22, 26, 27, and 31, and 69, the mean of this set is 35. However, the median is 27, a value that better describes the set. When there's an odd number of values in the set, the middle number or value is the median. For example, in a set of 7 ranked values, the fourth value is the midpoint. When there's an even number of values in the set, the median is the mean of the 2 middle values. For example, in a set of 10 values, it's the mean of the 5th and 6th value. Here are the steps in determining the median. Step 1. Rank the numbers in ascending or descending order. Step 2. For an odd number of values, the median is the middle value. Step 3. For an even number of values, the median is the mean of the 2 middle values. Here's an example. Determine the median for the following set of values. Rank the data in ascending order as follows: 2, 4, 5, 6, 8, 9, 11, 13, and 15. Because the number of values in this set is odd, 9, there are 4 values less than 4 values greater than the median. Therefore, the median is the 5th value, 8. The mode is the third measure of central tendency that we can consider. It's the value or values in a set that occur most often. It's possible for a set of data to have more than one mode or no mode at all. Here are the steps for determining the mode. Step 1. Count the number of times each value in a set occurs. Step 2. If one value occurs more times than any other, it's the mode. Step 3. If 2 or more values occur more times than any other, they are all modes of the set. Step 4. If all values occur the same number of times, there's no mode. Here's an example. Find the mode of the following set of values representing the wattage of light bulbs sold at a hardware store yesterday. From these data, we see that the mode is 75 watts because the value 75 occurs most often. This would indicate to the retailer that the 75 watt bulbs were purchased most frequently. The range is a measure of dispersion. It's the difference between the lowest and the highest values in a data set. It's used to measure the scope or broadness of a set of data. A small range indicates the data in a set are narrow in scope. The values are close to each other. A large range indicates that the data in a set are wide in scope. The values are spread far apart. Here are the steps for determining the range. Step 1. Locate the highest and lowest values in a set of numbers. Step 2. Subtract the lowest from the highest to get the range, where range equals highest value minus lowest value. Here's an example. Determine the range of the following shirt prices at Styline Men's Shop. Step 1 and 2. Subtract the lowest price from the highest price, where range equals $42.50 minus $14.95 for a total of $27.55. The number of values in each class is called the frequency, with the resulting chart called a frequency distribution or frequency table. The purpose of a frequency distribution is to organize large amounts of data into a more compact form without changing the essential information contained in those values. Here are the steps in constructing a frequency distribution. Step 1. Divide the data into equal-sized classes. Be sure to use classes that include all values in the set. Step 2. Use tally marks to record the frequency of values in each class. Step 3. Review the tally marks for each class numerically in a column labeled Frequency F. The data are now grouped. Here's an example. Construct a frequency distribution using classes with an interval of 10 pounds each. Here's the data set. Step 1. By using 10 through 19 for our lowest class and 60 through 69 for our highest, we include all values in the set. Class intervals of 10 pounds each allow for 6 equal classes. Here's an example of how our frequency distribution and tally marks would look. The means for grouped data are calculated by using the midpoints of each class rather than the actual values of the data and are therefore only approximations. Because the actual values of the data in each class of the distribution are lost, we must make the assumption that the midpoints of each class closely approximate the values in that class. Here are the steps for determining the mean of grouped data. Step 1. Add a column to the frequency distribution listing the midpoints of each class. Label it Midpoints M. Step 2. In a column labeled F times M, multiply the frequency of each class by the midpoint of that class. Step 3. Find the sum of the frequency column. Step 4. Find the sum of the F times M column. Step 5. Find the mean by dividing the sum of F times M column by the sum of the frequency column. Here's an example. Calculate the mean of the grouped data from frequency distributions for Monarch manufacturing in the example provided. Begin by attaching the midpoint M and the frequency times midpoint F times M columns to the frequency distribution. After finding the sum of the frequency of the F times M columns, use these sums to calculate the mean of grouped data. A histogram is a special type of bar chart that is used in business to display the data from a frequency distribution. A histogram is drawn in the same way as a standard bar chart but without space between the bars. Here are the steps for preparing a histogram. Step 1. Locate the classes of frequency distribution adjacent to each other along the x-axis, increasing from left to right. Step 2. Evenly space the frequencies on the y-axis, increasing from bottom to top. Step 3. Plot the frequency for each class in the form of a rectangular bar whose top edge is opposite the frequency of that class on the y-axis. Because a frequency distribution has classes whose numbers are continuous, the histogram bars depicting that distribution are made to look continuous by drawing them adjacent to each other with no space between them.